All right, so these problems are going to be similar to the last video. It's just that there's more than one variable. So 98, we're going to think of 98 as 49 times 2. And then we have a to the 7th. You can think of it as a to the 6th times a if you want. It might be easier to look at it that way. And then b to the 4th times b. So I'm making that first exponent to be divisible by 2. Okay. So now what's the square root of 49? 7. What's the square root of a to the 6th? A cubed. And so I'll have to have absolute value because it has an odd exponent. And, yeah. Okay, and then we have b squared, but I don't have to have an absolute value on that. All right, what's left inside? I have a 2, an a, and a b. And so that's the answer there. Okay, so now it's a cubed root. I don't have to worry about absolute value. I do have to try to think, though, of what is a perfect cube that goes into 56. 8, 8 times 7. And then I can think of it as x cubed times x squared. And I can think of it as y cubed times y. All right, the cubed root of 8 is 2. X cubed is going to get me an x on the outside. Y cubed is going to get me a y on the outside. And then I'm going to have the cubed root of 7x squared y. Okay, so that's that one. And then I think we have just one more here. So I need a 4th root. So 16 times 2 is 32. And then x to the 4th times x. And then y to the 8th, I can just leave it y to the 8th because 4 goes into 8. All right, so the 4th root of 16 is 2. The 4th root of x to the 4th is going to be x. Now, do I need absolute value? Yes. It's an even root, and I've got an odd number of variables that I took out. And then I'm going to have y squared. Does that need an absolute value? No, because it's squared. It's got an even exponent on it. All right, so all of the y's came out. I don't know if we've had that before where everything came out. All right, so we've got our 2, absolute value of x, y squared. What's left inside the radical? 2 and an x. And there we go.